For the lab today, I'm going to use an Arduino to read values from a potentiometer and then use those values to control the position of a servo. As you can see right here, I turn the potentiometer and the position of the servo changes as well. Here we can see that the location of the potentiometer controls the angle of the servo from 0 to 180 degrees. This is all done using an analog reading taken by the Arduino.
Right here we have the code on the right hand side, and on the left hand side we have the serial output. We can see as the potentiometer's location increases, the angle also increases. This is the digital to analog converter that will be used during the duration of this lab. As you can see, when all three switches are high, switch 1, 2, and 3, with the least significant being on the left and the most significant bit being on the right, the output is 4.3 volts. When we switch that, so now the most significant bit and the least significant bit are high, but the one in the middle is low, we instead see an output voltage of 3.183 volts. This is significantly lower because the input is now 5 instead of 7 in decimal. Lastly, we have the expected outputs from the digital to analog converter. This uses ideal values and assumes that there's no internal resistance in any wires that would cause any issues or inconsistencies. We use the voltage divider equation to find this and use a input voltage 5 volt. This causes us to have a 0.625 volt per digit. When we then use the three inputs to the digital to analog converter, we can then see the voltages that are expected output here. In addition, I did calculations to find what the servo angle can be using this digital to analog converter.
So here we have the resistor network that forms the digital to analog converter seen in Circuit Lab. We can see here when all the switches are high, just like we had in the Circuit Lab, that our output voltage is 4.12 volts. So a little bit lower than our 4.3 volts that we expected. Part of this is because my digital multimeter is not calibrated yet. Ever since building it, I haven't calibrated it yet. In addition, it could be from other wire resistances or other poor connections that are in the breadboard or the circuit itself. I'm also going to switch one of the pins and we'll see what the output is when we have a digital input of 5 instead of 7 like we have right now. I have now switched the positions of the center switch here. So our reading is now, if in digital, would be 5. And from the Circuit Lab, we know that this should be reading a voltage of about 3.18 volts. And we're seeing about 3.14 volts, which is very close. Part of the reason for that, again, is the digital multimeter is not calibrated yet. And part of it is also the losses and other problems that are in, or other inconsistencies in the circuit itself. Here we're controlling the servo with the digital to analog converter. This resistor network right here, as shown previously in Circuit Lab, is controlled by these three switches. It creates an analog voltage which is fed into the Arduino and uses the same software as the potentiometer to control the location of the servo. So you can see here all of the switches are high, meaning that this is in its maximum angle of 180 degrees. If we switch all of them back, you can see that we now have turned to its 0 degree angle. In addition to that, we can tell that this switch number 3 is the most significant bit because out of the 3, it creates the largest angle change. And with this 3-bit analog to digital to analog converter, we can get a total of 8 positions with this servo.
One of the ways we can increase the precision of our digital to analog converter is to just add more bits. Make it a 10-bit instead of a 3-bit.
Thanks for watching.